class. Today we will be having a guest speaker with us, Dr. Anjali.
Hello! Today in class we're going to be talking about states of matter and their differences in space. Let me start off with the definition of a solid.
A solid has a definite volume and a definite shape. The particles in a solid are tightly bounded and have strong intermolecular bonding, which leads to little movement between the particles.
Yeah, in space, densities are really important for classification as gravity is different wherever you go, so weight is not constant if you change places. Can we have a definition of a liquid?
Liquids have a definite volume but no definite shape, and this is because the intermolecular bonds are a bit weaker than solids, so the particles move around a little more.
Yeah, in space you don't find a lot of liquids. This is because of extreme temperatures. Like in space, it's negative 455 degrees Fahrenheit. And closer to the sun or stars, you get up to 50,000 degrees Fahrenheit. This means it's a lot of energy to keep something a liquid. How about a definition of a gas?
I'll take this one. Gas have no definite volume and no definite shape. This causes the particles in the gas to move at high velocity.
Yeah, gases are found in high temperature areas or as clouds of fine particles. The stars and our sun is actually a gaseous object. And gases, because there is no pressure to stop it, space is literally a vacuum, the gases just keep expanding with those loose bonds. So thank you guys.
So now that we've learned about states of matter in space, how is that important? With this knowledge, we can now make informed decisions about our Earth.
Oh my goodness, guys, I just got a message, and did you know that there's a YBTC runway happening right now? And they have scientists talking about different phenomena in space that relates to states of matter.
Shriya, you know you're not supposed to have your phone out in class, but I think we should watch this.
Hello! Today we're going to be talking about 3 different phenomena related to the states of matter in space. Here we have our first scientist, Kavin. What did you learn?
I learned about the composition of stars. As gas and dust started to collapse under gravity, a star formed. So it is initially made up of hydrogen, but after a few million years, it becomes hydrogen and helium. So once the hydrogen is all burned out of the star, helium nuclei will fuse together to make elements such as carbon, oxygen, and magnesium. When the helium exhausts, it will become the other elements will help the star survive for a few more million years.
Thank you so much. And now we have Anusha. What did you learn?
I learned about the largest water reservoir in space, which was just recently discovered in 2011. It contains more than 140 trillion times the amount of water present on Earth, but in the form of water vapor. This reservoir is associated with a black hole that is surrounded by gas and dust, giving off vast amounts of energy. This energy heats up the water vapor to about negative 63 degrees Fahrenheit. But to make this into a liquid form, it would be easier to convert it to a solid and then find a way to melt it in a higher pressure environment.
Thank you. And now we have Shriya. What did you learn?
I studied about the formation of planets and their composition based on the space accretion model. About 4.6 billion years ago, gas and dust particles in the solar nebula formed the sun because of gravity. And the leftover material created the planets in our solar. So solar wind basically pushed most of the gases to the outer edges, and that created the gas giants, which are composed of hydrogen and helium. And then the rockier, denser elements stayed closer to the sun and formed terrestrial planets. But there were some remnant gas left, so that created some light atmospheres.
Wow, very cool. Thank you to all 3 of our speakers, and make sure to tune in for a surprise interview. Bye. Hello guys, here we have 2 aerospace engineers here, and if you don't mind, we're going to be asking a few questions about your career. So what does daily work include, and what's your salary?
Being an aerospace engineer means that you can design different vehicles and systems, test them, and also work through different prototypes that can make a really good solution for space applications. And my salary is probably around 100K.
Sounds very challenging. And what does it take to get here?
Well, there's a necessary 4-year bachelor degree in aeronautical engineering, and also we need to have a fundamental understanding of states of matter in space, as well as there's additional training opportunities to work in the real field, like in the real life.
That's very inspiring. Well, thank you guys for being here.